Hey everyone, how's it going today? Welcome to our live stream. My name is Heather Gore and I'm in the product marketing group for MathWorks.
And I'm Adam Filion, and I'm also in the product marketing group at MathWorks. Thanks for joining us today on this live stream for what's new in MATLAB for release 2023b.
Yes, very exciting one. We're going to be sharing some of the highlights, new features from recent MATLAB releases, so maybe up to and including 23b. And definitely join us in the chat. I'll be monitoring questions. Let us know where you're coming from, what sort of things you do with MATLAB, and any questions you have.
Yeah, I'll kick the presentation off today while Heather keeps an eye on the chat, and partway through we'll swap. So let's jump in.
Awesome.
Just a brief agenda to kick things off. We're going to start with the most important topic for you to learn today, which is the release notes, where you can find all the various changes that are happening to MATLAB over the years. Then we're going to pick out a few highlights from 3 different areas. Our goal with these highlights is not to teach you everything you need to know about them. We're going to kind of explain what they are, show them off a little bit, and hopefully get you excited to go off and use them yourself. And then, of course, at the end, we'll wrap up with some resources. Those 3 topics we're going to focus on are things like low-code data analysis. So this is how you can get started importing, plotting, working with data really quickly without writing a lot of code yourself. Then we'll switch gears a little bit and talk about some bit more advanced topics in software development, things like source control and build automation. And then I'll hand things off to Heather to talk a bit about MATLAB and Python, including using MATLAB in Jupyter, which is really exciting.
Yes, it's a good release for all of this stuff.
Yeah. So the first thing up is MATLAB's release notes. Honestly, the easiest way to find MATLAB's release notes is to just go Google MATLAB release notes. But if you want to find it directly from MATLAB, from your MATLAB desktop, you can go to the big Help button up in the tool strip. This will open up your help documentation. And then over on the right, you'll see a place for release notes. If you open that up, you can then look at the release notes for any product. Every product has its own set of release notes. I'll just go look at base MATLAB. And here you can find every single change to MATLAB going back many, many years. Over on the left, you can filter down to just certain subtopics. So if there's certain areas you really care about, like let's say core math or performance, you can easily focus in just on those areas. You can also filter for certain terms, look at release ranges. But personally, every time a new release comes out in MATLAB, I always like to just open up the release notes and just scroll through and look at it, because there's so much great stuff in here, way more than we have time to talk about today.
Oh,
We'd
yeah.
be here for hours and hours and hours.
I mean, I guess we could be if you want, but
Yeah, I guess we don't technically have a hard stop on this, but
yeah, probably not.
We're going to try to keep it to a few highlights today.
But I like, I noticed how the little star, I think that's new. Is that new this release?
That's actually new in 23b, so that's
Okay.
that's a thing that's actually new about the release notes themselves. Is we started adding these little stars for what we call the release highlights. So these are some of the bigger, broader, higher impact features that we really want people to know about. So if you scroll down, you'll see there's one for an export function. So this will let you convert a MATLAB live script into Markdown or a Jupyter notebook, which is really exciting. Yeah, a little spoiler alert. We'll see that a little later. And further down, if you're using MATLAB, say, on a Mac, something new in 23b, MATLAB and Simulink are now running natively on Apple Silicon, which is really exciting. Of course, you've been able to use MATLAB and Simulink on Apple Silicon prior to this, but it ran in, I think it was called Intel emulation mode. But starting in 23b, it runs natively, which means it's both faster and also uses less power at the same time, which is great.
Very nice. It starts up super fast.
Yes, and startup is much, much faster. So always a lot of good reasons to upgrade to the latest MATLAB release, but especially if you're on Mac, this is an especially good release. And then, of course, you can, I just like to continue scrolling down. You'll see other exciting things. There's a new app for managing experiments in MATLAB. There's a new pivot table, which we'll talk a little bit more about a little later.
ODE.
ODE, yeah.
Sorry.
If you're a
you
core
talked
math
about
person.
math. You pointed to. You made a little arrow.
Yeah, ODE was basically my entire grad school.
Kids these days have it so easy.
Yeah, yeah. So release notes, the most important thing for you to learn today. If you care enough about what's new in MATLAB to tune into this live stream, as soon as this live stream's over, this should be the very first place that you go. But with that said, I'm going to hop back to slides for just a moment and introduce the case study we're going to use today. We're not going to worry about the details of this case study. We're just going to kind of use it to illustrate the new features as we kind of hop from feature to feature. But I wanted to quickly describe it so you know it's not just a random collection of code and data. So the data we're working with comes from NASA. This is some publicly available data. It's a series of sensors recorded from an aircraft flight from Halifax to Detroit. And if we were to go through all the details on this, we would import it, visualize it, clean it up, train some regression models. And we'll do some of that today as we go through and look at the new features. But with that, let's go ahead and hop over to MATLAB. All right, so if you've used MATLAB before, I'm sure this looks pretty familiar. We're going to start over in the current folder where we've got some data in an Excel file, right? And our first step, anytime we want to analyze some data, is, of course, we want to read this into MATLAB, get it down here in our workspace so we can play around with it. If you've used MATLAB before, you've probably done that. That's, getting data in from Excel is one of the most common things to do. You might know a command like read table or see the big import data button up there in the home tab. I use that all the time for something called the import tool. But we're here to talk about the shiny new stuff. So I'm going to open up what's called a MATLAB live script. So live scripts are a great place to create sort of almost like an interactive document. You can interleave rich text and code and outputs.
It's been really nice for creating blog posts, examples, teaching, that kind of thing. So you'll see lots of goodies in live scripts.
Yeah, exactly. Anytime you really want to clearly communicate an idea through MATLAB, live scripts are a great way to do that. Live scripts also allow you to embed interactivity directly into the live script. And I'm going to do that by going up here and adding what's called a live task. You see there's a bunch of them here. We'll talk about a number of them today. I'm going to start with just import data. So this adds the import data live task into my script. And this will let me go through and pick out any kind of data file MATLAB knows about. And it'll figure out what is this data file, what are, what's the function I need to use to read this into MATLAB. It'll take a best guess at the optional arguments and then show you a preview of the output. And you can see in this case, as you would expect from sort of a table of data inside of Excel, it reads it into a table of data inside of MATLAB. We've got columns with names, we've got values. We can see its size. It's almost 12,000 rows. But this isn't just sort of a normal table. This is a special kind of table called a time table. And Heather actually had a lot to do with sort of bringing this into MATLAB.
It's not triggering at all, Adam. I did not have 9 million bazillion meetings about this. But yeah, that's exactly right. It's basically a table, but the times are attached to it so that you can do very clever things. It'll keep track of all that whenever you're doing the more sophisticated data analysis stuff. Like when you show the tasks, you have more options for sorting and removing outliers and things like that. So it would take time into consideration in that case. So a lot of great stuff, especially for many MATLAB users or dealing with sensors, dealing with engineering, scientific kind of data. This is very common. So definitely check out Timetable. It's nice that it read that for you automatically.
Yeah, exactly. It does a great job sort of taking its best guess at sort of the defaults. It's bringing it in here as a timetable, which is super useful. I make use of it all the time. But if you think the defaults aren't right, you can always customize it, make your, get it the way that you like. And that's one of the great things about the live tasks is it embeds that interactivity right there in the script. If I'm done and I don't want to look at the controls anymore, I can just hide those. But this is actually kind of nice because it doesn't make it go away. So if I want to take this and I want to share it with somebody else, like Heather, I can collapse it so I don't have to look at it, but it's still there in case Heather wants to go through and say, oh, well, what happens if I take the script but I import a different file, right? The interactivity is still there. So that's a really useful part of it. So at this point, we've read some data into MATLAB. Now what? Now what do we want to do with it? I hear lots of different things. Do you have any particular favorites? Look at it, yeah.
Look at it. Some better than just numbers on
I always like, I'm the same way. I always like to plot it. And again, we're going to come back up to live tasks. And as you can see, there's a lot of live tasks. I'm going to open up the create plot, but there's a bunch of them for things like pre-processing data, working with outliers, or smoothing data. There's a new pivot table live task, so if you're a pivot tabler, there's now one of those for embedding it directly in MATLAB.
Right. And a lot of these things, I think they're just so super helpful, especially whenever you're dealing with smoothing, outliers, the kind of things that we were talking about. I don't always know what algorithm to use for smoothing. And so this helps. You can just try them out, and then maybe Adam sends it to me. Maybe I disagree, and I want something more, I don't know, sophisticated. I was trying to think of some cool smoothing algorithm off the top of my head. But it's really nice because you can just go back and forth. Super helpful for exploring and sharing.
Yeah, exactly. That iterative part of the workflow is a really key part of it. When we open up this create plot, we can see down here, we get a big gallery of all of the different types of plots that you can do in MATLAB. Let's say I want to start with just kind of a normal line plot.
Boring.
I can pick out, we'll start with the basics. We'll pick out our, let's say, time on the x-axis, and let's say I want to look at the altitude, because I generally have an idea of what the altitude of a flight should look like, hopefully in the good case. We'll start on the ground, go up, cruise around 32,000 feet, come back down, all pretty normal stuff.
Okay.
And then let's say I want to look at some of these other sensors. So in addition to altitude, we have latitude and longitude. We have some data about the oil temperature and pressure in the engine and the airspeed. So let's say I want to look at oil temperature. And that does not look very normal. You can see, okay, it's mostly between 0 and 100, and then it's dropping down to minus 400 there. And I don't care if that's Fahrenheit or Celsius. That's not a good sign.
No, it's definitely not. Like sudden freeze, sudden, maybe it's Kelvin.
Yeah. But whatever it is, this looks almost like a sensor dropout or some kind of sensor error. And this is a really common thing to happen in this kind of time series sensor data from real physical equipment. So this is something we'll probably want to clean up at some point. So we can look at these sensors, but this is a flight. I want to see its position. I want to look at something like latitude and longitude. And
check.
That's technically doing what I asked it to do, right? Like
check.
it's plotting latitude and longitude. Yeah,
Sure.
get a big check mark.
Yeah, that's good.
But it's a flight path. I want to see it on a map. So we could search for something or just kind of scroll through the gallery until we find something interesting, like let's say geoplot. There we go. So that looks a bit better. Now I can see it on a map.
Check on a map.
And like all the live tasks, there are some abilities to customize. There's some basic options here. But it's not possible to give you every possible customization through the live task, especially for something that has the depth to it of the MATLAB graphics system. There's just so many customizations you can do there.
Right.
So behind the scenes, all of these live tasks, as you're working with them, are actually generating the MATLAB code you need to programmatically reproduce those results. So in this case, it's just one call to geoplot and then creating the title. And if I wanted to use this as a starting point, as a jumping off point, to make more modifications, we can come up here to the top right and convert this task to editable code. And now this is just normal MATLAB code, no different than if we had written it ourselves from scratch. And this is a great example of what we call low-code tools. These are tools that let you do things interactively, iterate, kind of do it the easy way at once, and then generate the code you need to programmatically do the same thing. So you have the code you need in the end, but you didn't have to write a lot of it yourself. And this is one of the reasons why it's great, not just for beginners. I've been writing MATLAB code almost every day for almost 20 years, and I still use these things all the time, because at the end of the day, I just want to get my job done.
Yes.
And I don't especially care how I got the code that works.
Exactly. I think one of the biggest, the most traumatic one for me is the classification, regression, deep learning apps, where I spent, 6 years of my PhD working on like 2 or 3 algorithms and writing them in MATLAB and C++ and like type, and now, I can just click a button and try them all out. So although I love coding and, it's near and dear to my heart and I spent lots of time figuring all that stuff out, I'll click a couple buttons and go get a coffee and
yeah, exactly. You have the code you need at the end, and if you really want to code and customize it more, we can do that. So let's say I wanted to make some customizations to this. You know, I'm not terribly excited by this two-tone grayscale plot. If you ever want help on a command in MATLAB, just right-click on it, go to Help. That'll take you to the documentation. I hope you make very good use of the documentation. We're very proud of MATLAB's documentation. We think we've got the best doc in the software industry. If you want, you can start by going through sort of the syntax documentation, but I always skip straight down to the examples.
Definitely.
And just scroll through the examples until, you know, I see some things that start to look interesting. You know, we can do things like modify the line width, and there's a thing called the geo base map, which looks like it changes the background. So let's go back to our code. And if I start typing out some options, MATLAB's going to help me complete that. So let's say I want to increase the line width. And then I'm going to add a geo base map. And let's see here, what option are we feeling today?
Ooh, I don't know. Color
something like color terrain.
That sounds fun.
I want something colorful, so let's try color terrain.
Oh, yeah.
There we go. That looks a bit better. You know, we get some color for the oceans and the lands, and we can see, you know, where there's some deserts. So
we are landing in the middle of the ocean, however.
It does look like we're landing in the middle of the ocean. This looks like, you know, we've got another anomaly in our data.
I watch a lot of air disasters, so I was imagining the worst, but it seems like you're right, probably an anomaly.
Yeah, I think this is just a sensor
issue. Looks like
issue.
0, 0.
Yeah, exactly. Okay. It's 0, 0. Yeah, that's kind of a giveaway. And this is actually a fairly common thing with physical sensors. A lot of them, either when you first start them up or you're in the process of shutting them down, they have a certain default value they will output for a little while. A lot of them it's 0. Some of them it's something special like -99 or something. So you know it's a pretty common thing actually. Just more anomalies for us to clean up. So let's say we're happy, you know, kind of visualizing our data. We found a few anomalies we might want to clean up. So again, we can come back up to our list of live tasks, and there's a bunch of them here for working with pre-processing data, and again, doing some more exploration with things like pivot table. Let's say I want to look at the outliers that I had for that oil temperature sensor.
Yeah.
So again, we're going to pick out our flight data. Let's say I want to look at oil temperature. And like all the live tasks, it's got, you know, a bunch of controls up here, and it's taking its best guess and then kind of showing me the results. But its initial best guess says it's not gonna clean any. Number of outliers cleaned is 0. So okay, we're gonna have to fiddle with this a bit. And by default, it's going to show us a lot of information about what's going on. Personally, I always like to back up a little bit, turn some of this stuff off. Start with, you know, just kind of the basic input data here in the light blue, and then add the clean data in dark blue. And you notice it's a perfect overlap. It's not actually cleaning anything up right now. So here's where we can start to fiddle around with the options. So it's not detecting any outliers right now, so we probably want to mess around with how we're detecting them. So right now it's using a moving median, it's got a centered window, and it's going sort of 2 seconds at a time. And we mentioned earlier that we're using a timetable here. And one of the great things about timetables is they don't have to be regularly sampled. They don't have to be regularly spaced. You can have irregularly sampled data. And you can then do things like specify windows as a duration of time rather than a number of data points. Because if your data isn't regularly sampled, there will be a different number of data points in the same amount of time. And this is a really powerful ability to be able to tell it, hey, grab however many data points there are in, let's say, a 30-second window, and just kind of crawl through the data with that. And as we can see now, it's saying we detected actually a lot, over 1,000 outliers, but it captured all the main ones down here. The rest of it looks pretty reasonable. So it looks like maybe this is a good starting point for us to kind of iterate and tweak it further, and try to get it to the place that we like it.
Yeah, and that's a good example. I think this is a great example of having all those different options, because it's like, well, do I want to clean it with linear interpolation, or something a little bit more advanced, or the detection method? There's some pretty advanced mathematics going on there. So it's nice because you can keep going back and forth and visualize and try them out and see what makes sense.
Yeah, exactly. We can look at all the different types of detection methods. Moving median is the default, but we could look at something like grubs. I can't even tell you what grubs is, honestly, off the top of my head. I'd have to look that up in the doc. But we can just quickly flip through and experiment and see what's going to work best on our data set. So let's say we've used these low-code tools. We've kind of gone through our data. We've done whatever analysis and modeling we want to do. Kind of like a cooking show. I've shown you how to prepare the ingredients. Now I'm going to pull a finished meal out of the oven. So yeah. I'm going to open up a live script I've already created.
It's not that hard. It's just,
And in this case, I've added some extra comments, kind of explaining what's going on. We're going to start by importing data from Excel. I've also added what's called a live control here. You can find that under the controls option up here. And these are ways to add sort of your own custom interactivity into here. So it's not a task with sort of a pre-made thing for you to do. You can add in your own buttons, drop-downs, sliders, etc. To sort of kind of make your own interactive app.
And there are a couple of new ones this release too. I think the color picker is new and a couple of others. So definitely a good time to check those out. It kind of almost makes your script like a little app where somebody can try things out. Like we're talking about, iterate, keep playing around.
So as you can see in the script, we're going to kind of do all the same stuff that we just did. We're going to make a plot. We'll look at the oil data. Here we're looking at both temperature and pressure. We'll clean it up. And then train a very simple model, just make a little prediction. Nothing too complicated here. So for low-code data analysis, we talked about the tasks. For the sake of time, I'm not going to go open up any of these, but I always like to point out we also have up here in this apps tab a massive gallery, a huge catalog of apps. Unlike the live tasks, these do not embed in a live script. These are full-blown, full-screen apps for all kinds of different workflows. Connecting with hardware, image processing, signal processing. My personal favorite actually is the data cleaner, which is in core MATLAB. And this takes a lot of sort of the live tasks that we saw earlier for things like outliers and smoothing and gives it all to you in a single sort of workflow-based cleaning environment where you can play around with the steps and iterate on kind of all the different things.
Right. Oftentimes, I guess you want to do all of them.
Yeah, exactly.
So yeah, you can kind of string it along or have it all together in one app.
Do you have any favorites?
I like the deep network designer. Of course, I love the machine learning apps. That's near and dear to my heart and my background. But the thing I love about that is that, if you're working in AI and deep learning, you can actually, click into it. It's very visual. You can, just like anything else you've seen here today so far, you can change parameters, you can train models, you can visualize. So it just makes life a lot easier, for sure. So any of those machine learning ones are pretty amazing.
Yep. Yeah, so I think that's everything we're going to cover for low-code data analysis today. We're going to switch gears a little bit right now. Before we do, let's quickly check in any questions in the chat we want to address on air.
Don't see any. Okay. We had some nice introductions. People in solid-state physics. Me too. That's how I started. And then we have, the recording will be available at the same link, so you'll be able to see it afterwards, and even the chat, whatever questions we answer. So don't hesitate, keep asking questions, and yeah,
good stuff.
So far, so good. I guess you're explaining it very well since we have no questions yet.
Great. So we're going to switch gears a little bit now, and we're going to talk about a few bit more advanced topics in the realm of software development. So this kind of starts once we finish with our low-code data analysis, and now we need to think about, well, how are we going to share this thing that we've built? So we built a live script, so if I want to share it with somebody else who's just going to use normal desktop MATLAB like I'm using here, well, I can just send them the live script, right? But what if I want to send it to somebody who's not going to be using sort of desktop MATLAB? Let's say I want to send it to Heather and she's going to be using Jupyter. Well, as we foreshadowed earlier, in 23b, there is a new export command where I can give it the name of a live script that I have, and it can export it out to a Jupyter notebook.
And this is awesome. I mean, you've been able for ages to, save your live script as a HTML or PDF or, LaTeX or whatever. But, you'll see soon how easy it is now to save it as a Jupyter notebook and carry on if that's your platform of choice.
Yeah, exactly. This will just create a new file, which you can see over here inside of my current folder. And now it's taken all of the stuff from my live script and just translated it over to a Jupyter notebook. So this might be sort of the file that I want to share, but what's the mechanism I'm going to use to share it? Right? I'm sure we've all emailed just like a code file or a zip file before.
Yeah, definitely.
Might still do that sometimes.
Version 1, version 2, V2, V3.
Yeah.
Still guilty.
But there is a better way, and it's something that I encourage all of you to use, which is source control. Now, if you're new to source control, I'm not going to do a full primer on source control today. There's a lot of great learning resources available out there on the web. But the basic idea is source control is a tool that you can use to help manage and track changes to your code in your project. So not just what changes are happening, who made those changes, when did they make them, what was the reason that they gave for making them. You can use this to keep track of your history, revert back if you didn't like a change. I find source control often saves me from myself, which is, I think, the biggest thing that I love about it.
Definitely. Revert.
Yeah, exactly. But especially if you're going to work collaboratively, where you have multiple different people developing code on the same project, source control is really the only good way to do that. Now, if you want to use source control with MATLAB, you've been able to do that forever, basically. You could always use a direct source control client like Git Bash or Tortoise Git or something like that. MATLAB has also had integration with source control for a very long time. I actually forget when it first started. Do you remember?
I want to say 2014.
Yeah, I want to say like 14b or something.
Yeah, I think so.
Long enough ago that I don't even remember when it happened anymore. Over in the current folder, you can see that there is a column for source control. I'm using Git here today, which is one type of source control. And you can see the little the status. So the little green circle means, hey, everything's up to date. There's no changes you need to worry about. The blue square means there's some changes that I've made locally, but I haven't shared with anybody else. So for example, if right now I was to tell Heather, hey, I made some changes, you can go get them, she's not actually going to see them. They haven't left here yet. So if you want to interact with source control, the right-click menu in the current folder has had an option for source control for, again, many years, I think going back to 2014. And it's got all the most common things you want to do here. So commit your changes, push them so others can see it, work with things like branches and submodules. Excuse me. But in 23b, there is now a native Git API built into MATLAB, where you can initialize a new Git repo, you can clone an existing one, or just get a handle to the one that you're already in. So if we look at what's inside of what this returns a MATLAB object, and we can see things like what's the folder where the information lives, things like branches, modified files, files that are in here that we're not tracking with source control. We might want to be tracking them. And so now using this, I can actually script and automate my interactions with source control, which is fantastic. But let's say I forget to do that, because I'm a really forgetful person. So let's say I'm going to switch and look at a different tool now that helps with sort of automating software workflows. So I'm going to tab over to slides for a moment to help explain a concept here.
All right. It's fine. No slides usually, but this one is important.
Yeah. Usually I like to try to keep the slides out and just focus on MATLAB. But this one, it helps with the concept because there's one concept and 3 different parts to it, and they're all named kind of similarly.
Right. And if you've used these kind of concepts before, it's just good to get a good sense of what we're talking about.
Yeah, exactly. So the parts of the system is build tool, build file, and build plan. And the idea is you can use build tool to automate software workflows. What that is going to look like is going to be different for everybody. It might include things like interacting with source control. It might include automating, exporting your live scripts to Jupyter, like I did. It might include things like p-coding files or mexing them or building an app or whatever it is that you need to do. And you're going to automate these software workflows using what's called a build file and a build plan. So what are these things? So a build file, as the name suggests, is a file. It's a file that's going to live in your project. If you use source control, it'll be under source control. And it's just kind of a normal MATLAB function file, but with two special rules. Number one, it has to be called build file. That name is important. And the second is it has to output what's called the build plan. So what's the build plan? This is something that gets constructed inside of the build file. We'll take a look at a more detailed example in just a moment. But if you were to open up this build file, you'll see the output is going to be the plan. And this plan is a MATLAB object that contains all the different steps your project needs to go through before you're ready to share it, as well as the dependencies between them. There's a bunch of different ways to create that plan, but probably the most common is just going to be build plan, the command that you see there. And we can actually create a plot of all the different tasks that we can do as a part of this project and their dependencies between them. So in this little example, there's 3 different things that I might want to do with this project. Check the code. And so this is going to use MATLAB's code analyzer to check for potential problems. This is like the yellow and red squigglies under your code. There's a test. So this will run software tests that we've written using MATLAB's unit testing framework. And there's an archive step to just archive our code somewhere. But if I want to archive my code, I don't want to archive bad code. So here we made archive depend on both the check and test steps. So anytime you try to archive, it's first going to run check, and then it's going to run test. And only if those both pass will it then archive it. So it's a way, again, a bit like source control, it's a way to kind of save you from yourself and make sure you're not going to be archiving bad code. So that's what the build plan is. It contains all the steps, the dependencies between them. And then if you actually want to use it, this is where build tool comes in. Build tool executes the build plan.
Makes sense.
You run this from the command window. Something I really like is if you say build tool -tasks, this will just print out all of the tasks that are a part of this project. This is both a great reminder for yourself. It's also great for anybody else who comes across your project. If they see you've got a build file, oh, I can just do build tool -tasks. Oh, cool. Here's all the things I can do with this project. And then if I try to run the archive tasks and say build tool archive, as you can see, it's not going to immediately archive it. It's going to start the check task first, because that's a dependency. Once it passes the check stage, it's then going to start the test, because it also depends on test. And it's only going to archive if both of those succeed. So this is a really powerful feature. It's not brand new in 23b. It actually came out a year ago in 22b, and then it's had some really nice continuous improvements in 23a and 23b. And so it's something that I really encourage all of you to go learn more about. I've started adopting this in just all of my projects to help automate things.
And even, I think sometimes when we're talking about this stuff, it's like, oh, geez, like CMake or like building, like this all, it sounds so complicated. But the way you're going to show it here, just even something like sharing your code with Heather is warranting a build plan and file and execution. So I think it's a great example of how you might actually adopt this easily. Yeah,
exactly. And my sort of rule of thumb for it is anytime I have more than one step I need to do before I share what I've done, I put that in a build file and make a build plan, because I know if I don't, at some point I'm going to forget some kind of a step along the way and get myself in trouble.
Right.
And I'll go back to it again because I love our doc so much. If I went through that a little fast, explaining what that is, we have some great documentation on build tool, and I go to it so often I actually have it as a favorite. If you didn't know, you can favorite MATLAB doc pages, so you can find them quickly again, because
wow, look at you.
I always need to go back to the same pages.
Unit testing and build tool. You're so fancy software developer.
And here you'll find just an overview of the build tool, kind of what I explained, but going in a bit more depth, as well as a really nice just example build file that it'll walk you through and kind of explain what it's doing. So as I mentioned, for each of you, your build file is going to look a little different because everybody's workflow is a little different. This is what I'm going to show you is just one example that I cooked up for today. And so what you can see, again, I opened up the build file. It's in my current directory, and it's going to output what's called the build plan. The build plan we're going to create from our local functions. If you didn't know, you can create what are called local functions inside MATLAB function files. So this function here, you see, okay, I start with the function, I end. But if I scroll down, you see there's more functions inside of this same file. And these work exactly the same as any other function in MATLAB, but they can only be seen inside of this file. So they have a limited scope. And here, I've defined 2 custom tasks that I want to do. I want to be able to push to my Git repo. I want to share it. And in order to do that, I'm just going to get a handle to my Git repo that I'm currently in, and then I'm going to push. And when that's done, I'm just going to output a little helpful message saying, hey, this worked. The other thing is I want to check my Git status. And this is the step that I often forget. So here I'm going to assert that my local Git repo has no uncommitted changes. I haven't forgotten to commit. So again, we're going to get a handle to this Git repo. And that just maintains a list of what are the modified files. So what are the files that have changes in them that I have not committed to source control. Then I'm going to assert something. I'm going to assert that this statement is true, that that list of files is empty. If that is true, if it is empty, if there's no modified files, great. It just continues, and it'll say, hey, OK, all the local changes are done. If that is not true, it's going to error, and it's going to print out my custom error message. Here, local repo contains uncommitted changes. Hey, you forgot to commit, right? So these are the 2 custom tasks I'm going to use here today. Yours is going to look different. And the great thing about this is anything you can script in MATLAB, you can automate with Build Tool. If you know how to write the code to do it, you can automate it here. And that's really powerful.
Yeah, that's really nice. Especially, I think it's a great example using the combination of Build Tool and the new GitHub API access, because again, that's something I'm like, what branch am I on? Like, what changes have been made? I mean, even working together on this project.
Yep.
So yeah, I think it's a really great example of something that's common.
Yeah, so as soon as I saw the new Git API come out, the very first thing I thought about was getting that in my build file, because that's a step that I'm so bad at remembering.
Yes.
So we can create the build plan from local functions. We can define any kind of function we want. But certain ones are so common that starting in 23b, there's some built-in ones for it, like the code issues task. This will use MATLAB's code analyzer, and it will look for all of the warnings and potential errors the code analyzer identifies. So I'm sure you've seen sort of the yellow and red squigglies under your code before. Hopefully you don't just ignore those.
I love those.
But the code issues task will look at all of the code in your repository, and it will figure out, well, which files are generating warnings and errors. By default, this task will fail if any of your code produces an error. And so this is going to stop you from sharing code that MATLAB knows before you share it, it's going to error if you get there. We can also customize it. So let's say I want to make sure I'm only sharing really good code. I can set the warning threshold to 0. By default, it won't stop if there's warnings. It'll just say, hey, there's some warnings in your code. But if I want to make sure that I'm sharing really clean code, I can set this to 0. So now the build is only going to complete if there's no warnings or errors anywhere. It's also a good idea to define a default task in our plan. So if I don't tell you what to do, what do I want you to do? So let's say I want you to push. So if I don't tell you what to do, just go ahead and push it. But before you push it, there's some things I want you to do. Because like we talked about on the slide with archiving code, we don't want to push bad code. So we're going to add some dependencies. And we're going to say the code check, which I created up here, and the get status, which I defined in a local function down below. These are both dependencies of get push. So before I push, it's going to check my code. It's going to check the get status. And only if both of those pass is it going to push to my remote repo. So now let's say I go back to my command line. If I say build tool -tasks, it's going to tell me, hey, OK, here's the things you can do. You can check your code. You can push it. You can check the get status. If I just say build tool, then by default, it's going to start running through. It's going to run the code check. It says, OK, you've got 3 MATLAB files. There's no errors. There's no warnings. So you're good to go on that front. Then it's going to start the get status, and it's going to error. And it's going to error, telling me, hey, you didn't commit things because
so embarrassing, Adam.
I forgot to commit.
You didn't even flinch. You got an error. You didn't even get sad. You must be doing this a while.
Well, I have the audio turned off, so I don't have the beep at me today. It's the beep that makes me flinch.
It's like, oh gosh, again.
So if I want to commit this, again, lots of ways you can do that. I'm going to use our new API. So I'm going to commit. I'm going to use the handle to my Git repo, and I'm going to give it a message. Giving it a message is always helpful. And I didn't actually really make any changes today. I just changed a little threshold, so I'm just going to say, updates for Heather. But usually you want to give a descriptive message here of what are the changes that you made. So I'm going to commit this. And again, one of the nice things about source control is when you commit something, You're not just making a change, it's tagging it with a message related to this change, and it'll tell you, hey, who changed this, when did they change this, and how do I get a hold of this person if I don't like what they did?
Yes, it's basically the blame.
Yes, exactly. Who do I blame for this change? And this is such a super helpful thing to keep track of things. So now that I've made that commit, I'm going to run build tool again. And again, it's going to start my code check. Still passes because I didn't change anything in my code. And then it's going to run get status, and now it says, hey, cool, all local changes are committed to get. So now we're going to push, and the push worked. So now all of those changes have been pushed out to our remote server so that anybody else can go grab it. So
Sweet.
That's going to wrap it up for our second topic. We talked a bit about source control. You've been able to use source control for a very long time in MATLAB, but we've got the new Git API in 23b. And we talked a bit about build tool for automating more complex software workflows. Build tool isn't brand new. It came out in 22b. It's a little over a year old, but it's had some nice enhancements over the last year as well. And with that, I think that's it for my portion of it. So at this point, I think we're going to throw it over to Heather to talk a bit about Python and Jupyter.
Yeah, sounds good to me. And while we're switching over, team, we're going to answer a couple questions because there were a couple that were related to Mac.
Yep.
So one was thanking us for the long-awaited feature. So thanks to Scott Nicholas, has been working very closely with Apple and getting this running well. So the question was, do the add-ons also run natively? Yes. So everything pretty much should. There likely are exceptions. I believe there's a list somewhere. Some toolboxes are only Windows supported. Some of the compilers, things like that. But pretty much whatever you're using, I haven't run into anything so far that hasn't been supported. And right. I think there's, you might be able to find a little bit more info in the notes that Adam showed.
The vast majority, like 99 point something percent, just works natively, because the thing that really mattered was MATLAB's really kind of core fundamental libraries, the real guts of MATLAB that everything else depends on. The vast majority of add-ons don't have any special real libraries, like compiled libraries. They're just MATLAB code files that run on the same engine. So yeah, every add-on should also run natively. Yeah,
nice. Then another question was how to get files. So if, say you're working on a Windows machine and you are now switching to a Mac, like me. Or Linux every day, going back and forth all the time. So there are multiple ways to do that. What Adam just shared with GitHub is probably the most, precise way. And you can keep track of things, especially if you have internet. Also, if you notice, I'm kind of doubling up because I'm using GitHub and I'm also using MATLAB Drive. So that's kind of like a, shared folder that comes with your MATLAB Online. And it's a really easy way to share things, especially if you have somebody that's just like not interested in GitHub, that's not that kind of situation. You can actually share a link for someone to run your code and contribute through MATLAB Online and MATLAB Drive.
Yeah, MATLAB Drive. It's if you're familiar with things like OneDrive, things like that. It's very, very, very similar, but it comes with natural hooks into the MATLAB environment. And you can even have it sort of be a pointer or a wrapper around sort of other remote repositories as well.
Right.
So it can be a really convenient thing when you want to work with MATLAB, sort of in a cloud environment directly, or cloud-like environment and things like Jupyter Lab.
Yeah, definitely. So I'm going to go ahead and, I guess I won't do it just in case it errors. But I did it right before this. But in theory, I would pull from Adam's repo. And, I also have a Jupyter GitHub client added on. And there was a question about why would I use Jupyter? Like, what are we even doing this for? So I guess before I jump into showing everything, even though it's way fun, one of the reasons is, especially, we see a lot of times where people are doing, AI and engineering kind of work, you're bouncing back and forth between MATLAB and Python. It can get a little tedious to have both desktops open, to have all kinds of, I don't know about you, but I'll have like VS Code open, Jupyter, MATLAB, all sorts of things. So in this case, it's really handy, especially if you're kind of Python primary. And you can see, it's a great way. I mean, I like JupyterLab in general because, again, if you're kind of bouncing around between different languages, like if I'm working on a deployment thing, I can open up my, JSON, my, JavaScript, whatever, kind of all in the same place. So, in fact, you can even open a MATLAB. So I think, I already have one open. That's okay. No big deal. So that's one thing. If you've seen any of my previous work on MATLAB and Python, previously, you could obviously always call MATLAB and Python together since 2014. But this is, again, I'm not opening a proper MATLAB. I was opening this through JupyterLab, and I can do, whatever. I don't know. Do you have a favorite function?
Well, I was going to say, do I see dark theme there?
Oh, you sure do. Yeah, that's also a nice reminder that there is a beta dark theme for the new desktop, and the MATLAB Online interface has an option for changing to proper dark theme. So another good what's new.
Yeah. I was excited to see that come to MATLAB Online, and when you open a MATLAB from JupyterLab, you may notice it's booting MATLAB in the browser, and so it's actually running sort of MATLAB Online, but it's running it locally. So you get a lot of the cool stuff that has come to MATLAB Online, but not yet MATLAB Desktop. And if you're interested in trying sort of the next version of MATLAB Desktop, there is a beta going on right now out on the MATLAB File Exchange where you can try out a new version of the desktop. I will remind you, it is a beta. It's not quite as fast or as polished as the normal MATLAB desktop is. It's there for you to experiment and try new things that aren't quite finished yet. But it is exciting, and it's got some fun new features, including dark theme. So check out the File Exchange if you want to play around with that.
And it's really great because this is the time we actually need feedback, right? So if you don't like the way something looks or feels, this is the time to let us know.
Yep.
So anyway, I'm using MATLAB. It's great. It's my favorite. It's the good old MATLAB that I know and love. But let me go back here, and I'm going to open up that bit of code that MATLAB that Adam shared with me. So let me clear all this stuff. And notice I'm using a MATLAB kernel. So there's easy installation instructions through all operating systems. No big deal. We can share that into the chat, and I'm going to forget all of my my shortcuts because that's my life.
That's what happens when you bounce around between three different operating systems all at the same time.
Yes, exactly. Oh, what are you doing, man? All right, really?
The joys of bouncing between operating systems.
I know.
We had a question about that in the chat earlier. What's the best way to kind of share MATLAB software from, let's say, an HP computer to an iMac? And again, we've talked about two of them today. Source control is the big thing that I always go back to because not only is it a great way to share, it's a great way to keep track of changes and what changes are happening when. And if everything's under source control, you could just revert if you hit a weird error most of the time. MATLAB Drive is another good way to kind of share code and work on it collaboratively. One of the fun things that can happen, though, if you're bouncing around is, directories.
Exactly.
This is often this is often a pain point when you're bouncing between operating systems.
All right, so I do have this on the path. Okay, let me see. Let me restart. So this is good though because it's useful. So at least it's actually realizing that I'm trying to do something in MATLAB, and it's finding that. It's just not finding the file.
I think it's not finding it from the MATLAB drive. Do you want to just put flight data.xlss and delete the rest of the path?
Oh, you're right. Sorry.
Because I think it's thinking that there's a MATLAB drive from your current folder.
Windows thing, maybe. Oh, jeez.
All right.
Okay, maybe not. What is happening? I swear.
Do you want to bounce back to mine? Since it's all on Windows, we don't have to worry about that stuff.
Maybe. But before that, I did want to mention, we'll show that in a second, but it's also possible to run, Python from MATLAB, like run a Python through the API, or I'm sorry, run MATLAB through Python through the MATLAB Engine API. And so this is good if you in case let's say I don't care about Adam's crap and I don't need to run it. I'm just going to do my own thing anyway. I can, well, this is probably not going to work because it's the same, it's going to be the same error. You never know. Let's see.
It's a different API.
All right, very good.
The difference here is it's not actually using the MATLAB kernel. If you look in the top right, it's using a Python kernel. So this is a Python notebook. So you can be sort of in a Python first environment. But then from there, call into MATLAB sort of when you need it, which is what you did.
Right.
Just there, calling the read and clean function from MATLAB.
Exactly. And so now, I can take advantage of it in a different way.
Yeah.
And, not have to show you all of my settings live on YouTube. And then I can convert it and go along with my business. Let's say I'm angry about these silly apps and I really just want to write code and I don't want to have to, I don't know, make my life really easy. I can use, whatever. Actually, this is a nice example because I think this isn't as easily supported in MATLAB, just gradient boost. You have to do some adjustments and things like that.
Yeah, exactly. There's a lot of more niche or other types of models available out there in the open source system. So if you want to use MATLAB to do kind of your import and pre-processing preparation, things like that, but then be able to call whatever sort of Python model that you want, you could do exactly what Heather's doing here. One line to call a MATLAB function, give it the directory name, it'll read it using MATLAB, do the pre-processing, pass it back as a data type that Python can work with, and then you can feed that into whatever other Python code you want to use.
Yeah, it's perfect for, especially if you're trying to replicate some code or a paper or something like that. Makes life easy.
Exactly.
So do you want to switch back and you can run your
we can
code since I failed, even though it looks like it's on the path. Okay, whatever, I'll restart it.
We can switch back to my my screen. We'll give our guys a second to do that for you all.
Great. Don't forget to ask questions.
Yeah. And as we're kind of switching back, are we there yet?
We're getting there.
Okay. So here we're back on my laptop, and you can see, as we saw earlier, this converted the live script into a Jupyter notebook, so it's got all of the text, it's got the comments, it's got the code sections, it's got the visualizations. But now I can go through and let's say I want to kind of just run everything.
Ooh, works for you.
Yeah. I'm still really old school. I still do everything on my C drive, which is probably not the best idea. But I'm still old school like that.
That's all right. It's working.
So I went through it.
You win.
Yeah, I read that. And we can, we get our plots, kind of all the same results that we had. But now we can use this entirely within the Jupyter environment if we, prefer that for sort of multilingual development, right?
Yeah, and again, I think it's a good example. Someone had asked a question about, when do you use that one versus the other, and we see it very commonly when, again, you're popping back and forth a lot between different, code bases, and you can even combine them together. And so again, it's super handy. Just pop open a MATLAB. You can even, use the interactive stuff. You can use the apps through that same MATLAB. So really makes life a lot easier, especially for me whenever I'm working on Python code.
Yeah, exactly. So we're getting near the end of the hour. So let's go ahead and wrap up. I'm going to give you a few reminders of some of the things that we talked about today, and then we'll talk about some resources you can use after today. So we started off today talking about low-code tools in MATLAB. We looked at just 3 of them. There's actually a lot. There's over 100 low-code tools for things like data analysis, engineering, and AI.
And I feel like it's just almost the name of the game, right?
Yeah.
In MATLAB, it's just you can kind of expect to be able to click on things, to be able to interact with everything, and then also be able to access the code.
Yeah, exactly. This is something MATLAB's been doing for a very long time. The earliest one I'm aware of is what we used to call the curve and surface fitter, what is now the curve fitting tool. And that came out in, I want to say 2003. I think it's been around 20 years we've been doing this in various forms. And there's over 100 of them now. In data analysis, you saw some things today for visualizing and manipulating data. As mentioned, pivot table is new in 23b. When it comes to engineering, we've got tons of them for controls and signal processing and image processing. It's not a new one, but it's still my favorite. This is the signal analyzer. It's such an awesome tool for looking at different signals in both the time domain and the frequency domain. It's very cool for that kind of exploratory data analysis with signals.
I don't know about you, but I live in the time domain, so I need help in the frequency domain.
In the frequency domain, yeah, especially. And then when it comes to AI, we again have a bunch of apps here to make really iterative or complicated workflows much simpler. Things like labeling data. Labeling data becomes so much simpler when you have interactive tools to do it. Doing things like network design, like the network designer that you can see here, so you can kind of explore all the different layers in a network and play around with them, figure out what you want to use. And even quantizing these networks, so getting them to be able to run on really small embedded processors that can't handle these enormous models that people are using these days. How do you do that? How do you shrink a model down to fit on an embedded processor? There's apps for all of this. We talked about programmatically interacting with Git. You've been able to use source control for a long time, but new in 23b is the Git API that we saw. We talked about build tools for automating software workflows. This first came out in 22b. It lets you write tasks in MATLAB code, declare dependencies between them, visualize it, run it. We saw you can use build tool -tasks to list the tasks and then build tool to run things. And it's had some nice improvements over the last year. We talked about using MATLAB and Jupyter. So the Jupyter support is actually not tied to any particular release. I think it's tested back through something like 20b or 21b for a couple of years.
Yeah.
It's been tested back. The support first came out in January, I think, 2023, January, beginning of this year. That was Linux and Mac, and then Windows got added sometime around like June, I want to say. If you're interested in learning more about this, or you want somebody to kind of walk you through the steps, I encourage you to look at our blogs on MathWorks.com. Mike Croucher writes an awesome blog on MATLAB on MathWorks.com, and he has a couple of entries on using MATLAB with Jupyter. And then, again, new in 23b is the export command to automatically translate things to Jupyter notebooks. When it comes to interfacing MATLAB with Python, there's been a ton of new stuff over the last couple of years. New commands pyrun and pyrun file, so you can use this inside of MATLAB to run Python code and return it back. So this is kind of the opposite of what Heather showed you in Jupyter. This is when we're in a MATLAB first environment, but we still want to be able to run Python code. That's where pyrun and pyrun file are great. A lot of syntax improvements. And then the big thing is data transfer. How do I transfer data back and forth? So over the last year and a half, date time and duration got added, lists and tuples of numbers and strings and dates and date times, and even NumPy arrays can be passed directly in some circumstances. And this is an area we're actively working on and continuing to improve, is how to passing the data back and forth.
Right. Just trying to make life easier whenever you're doing these things.
Whenever you want to use two languages together, getting the data to interface is always one of the friction points.
Especially with machine learning and AI, you have multiple data types, containers, things like that. So, yeah.
Yep. So I think that's about it for the new features we're going to talk about. I'm going to quickly wrap up with some places where you can go to get more help after today. And one of them is MATLAB Central, which is our community. There's over 2 million monthly active users of this community for MATLAB and Simulink. There's a bunch of really awesome places. There's MATLAB Answers, which I go to all the time. This is a great online Q&A forum. So if you ever have a question, you don't know, you can't find an answer on Google, you don't know where to go, post it on MATLAB Answers. It's very active. Most questions get an answer in under an hour. There's the File Exchange, where you can go to download tools other people have built in MATLAB. We mentioned the beta for the new desktop that's available on the File Exchange. And there's some fun other places, Kodi, which is kind of a place for sort of gaming, programming games, and blogs. As I mentioned, Mike Croucher's blog, and a number of others are really great.
Yeah.
If you want more direct support from MathWorks, we have a lot of options. We've got fantastic technical support. That's actually where I started at the company. We've got full training, full consulting, online on-site workshops, kind of everything that you would expect from kind of professional software support. And if you want something hands-on just to help you get started, like if you're new to MATLAB or a concept, we have what we call on-ramp courses. These are free, 2-hour. They run in your browser. It's hands-on. You're walking through. And you can find these on our website on a place called MATLAB Academy for basic MATLAB, as well as things like signal processing, image processing, deep learning, and a bunch of other topics.
And those are nice because it gives you the concepts too. You know,
Exactly.
I kind of needed to catch up on signal processing and controls, things like that.
Yeah, exactly.
Working on AI, so those are super helpful for me.
Yeah, if you're new to it, or if you just need a refresher on it, right?
Right.
And I think that's about it for the planned content that we had. We answered a number of questions from chat. Any last ones that we want to
just have one on the import data task. Is there a way to change the columns and rows to be imported, kind of like in the normal import data tool?
Oh,
Do you know, like I guess selecting.
So it's sort of selecting which ones to read in, I guess. I don't think that's there yet. As I mentioned, the import live task is new. I think that was new in 23A, if I remember right. As you can tell, there's so many new things coming out in MATLAB, even we have a hard time
I can't keep track.
remembering when they all come out. So I don't think that is there yet, but that is a great enhancement request. And I will say, if you ever have requests like that, please do reach out and let us know. The biggest thing that we use to prioritize what we build next is what our users tell us they want. So never assume other people want the same thing. If you have a request, please reach out and let us know. That's the biggest thing that drives what we build next.
Yeah.
So I'll pass that along to our developers.
Yeah. Awesome. Yeah. Feel free to put it in the comments, or hit us up on social. Like and subscribe. We'll be back. But yeah, any questions you have, suggestions, we'd love to hear it. Great to hear from everybody. Doesn't look like we have any more questions.
Cool. I guess that means we did a great job.
So I think we answered everything before you knew what to ask.
Okay. Great.
So yeah, thanks everyone. This is awesome. Happy 2023b.
Yeah.
And stay in touch. Share some of your exciting MATLAB things that you're creating with us, and we'll see you next time.
Yeah, we'll see you next time. Have a good one, everybody.
Okay, thank you.
Thanks. Bye.